Okay, good. My talk is about the next generation launch system that SpaceX is developing. That's the first stage being the Super Heavy and the second stage being the Starship. Now, this new launch system is really amazing in its capabilities, and it's going to be a real game changer. Don't know what happened there. Oh, I pressed the wrong button. This figure shows the relative size of the various launch systems. The Super Heavy Starship will be the largest launch vehicle ever, also by far the most capable. And it will be fully reusable. Now, this means both stages will be reused, whereas for the Falcon 9, only the first stage was reused. And Elon Musk has stated that the cost per launch will be less than that of their Falcon 1, which was their first launch vehicle. And that was a really small and very inexpensive launch vehicle. The cost will be a lot less, a whole lot less than the current, their current launch vehicles, the Falcon 9 and the Falcon Heavy. And as a result, the plan is to eventually replace the Falcon 9 and the Falcon Heavy with the new launch vehicle. This is the Falcon, or the Super Heavy, and one very distinctive characteristic is that it has a lot of rocket engines. So in the base of the rocket, that's up here, it can fit 37 rocket engines. Now, Elon Musk has said they might not equip it with all 37. It might be something more like 31, but it will be a lot of rocket engines. This is the latest configuration of the Starship, and it's got two larger fins on the bottom and two smaller fins on the top. And those fins are for aerodynamic control in the atmosphere of the Earth or in the atmosphere of Mars. And it's also got 6 landing legs that pop out right before landing. Now, there are 3 versions of the Starship. There's the cargo version that can launch commercial satellites, military satellites, science missions, or it could take cargo to and from the International Space Station, or it could actually land cargo on the surface of the moon or on the surface of Mars. Then there's a version that carries crew. That version will have windows. And the third version is a tanker version used for orbital refueling. The Starship is designed to land on the Earth, but it's also designed so it can land on the moon, and it can land on Mars, and it can land on other objects in our solar system. For instance, it could transport a large robotic probe to Europa, which is a moon of Saturn. And the payload capability of this launch vehicle is amazing, that with orbital refueling, it can carry 100 tons of cargo or 100 people to the surface of the moon or to the surface of Mars. So this is how it would work on a mission to the moon. And the Starship would first be launched into an elliptical Earth orbit, and then it would be refueled by several of the Starship tanker versions. And once it's fully refueled, then it would depart for the moon, land on the moon, and then return to Earth. Now, the key new technology here, which is quite important, is the orbital refueling. And the reason that's important is that with the orbital refueling, you can more than double the payload that you can send to the moon or to Mars. So with the orbital refueling, this will actually be able to land cargo or people on the moon and return back to Earth without having to be refueled on the moon. And that's important because so far there are no gas stations on the moon. And this is a artist's conception of the Starship landing at a base on the moon. So here's how it would work for a Mars mission. The Starship would first be launched into an elliptical Earth orbit, and there it would be refueled by several of these tanker Starship versions. And once it's fully refueled, it will depart for Mars, and it can land up to 100 tons of cargo or 100 people on the surface of Mars. Now, once on Mars, to bring the Starship back to Earth, they would have to refuel it using propellants which are produced on Mars through in situ resource utilization. But then it can fly back to Earth and be reused for other trips to Mars. And the astronauts can come back to Earth if they choose, but perhaps some of the astronauts might decide to stay on Mars to set up the first human settlement on the red planet. So this is an artist's conception of what a settlement on the red planet might look like. And you can see some starships in the background. So this year, SpaceX has been actually making very rapid progress on the Super Heavy and Starship. It's been rather amazing. Elon Musk realized that the Starship would be the most challenging aspect of the launch vehicle. So what he did, he built a test vehicle called the Starhopper. Now the Starhopper has the same diameter as the Starship, but it's much shorter. And it had some flights at first where, at first it actually had, it was tethered to the ground, and they did some tests with the rocket engines while it was tethered. But then it had a couple of flights, and the final flight was on August 27th of this year. And the Starship rose to an altitude of 150 meters and translated laterally, and then landed on the center of a landing pad close to where it had taken off from. The Starhopper was able to verify the Raptor rocket engine. It only had one Raptor rocket engine, and that includes the gimbaling of the rocket engine to control the flight. It also verified the methane and liquid oxygen propellants, and this is important because methane is a new fuel that has never been used before on an orbital launch vehicle. It also verified the vertical takeoff and landing capability. And finally, it verified the stainless steel rocket casing. So in addition to the Starhopper, SpaceX is building, in fact, they're nearly complete with two full-scale Starship prototype vehicles. They're being built by competing teams. One of these teams is at their future launch site in Boca Chica, Texas, and that's the Mark I prototype vehicle. And the second team is located in Florida, close to Cape Canaveral. They're also planning to build more Starships. Once the Mark 1 and 2 are completed, then the Texas team will build the Mark 3 Starship, and the Florida team will build the Mark 4 Starship. Now, the Mark 1 and Mark 2 prototypes will only have 3 engines, and those prototypes will only be used for suborbital testing. But that's Mark 1 and Mark 2. The Mark 3 and Mark 4 will have 6 engines, and those will be used along with the Super Heavy for orbital flights. So the next milestone is going to be suborbital testing of the Mark 1 and Mark 2 prototype vehicles. And the Mark 1 is nearly finished. It needs a little bit of more work on the rocket engines, but its first flight is expected next month in November, and that will be to an altitude of 20 kilometers, which is a whole lot higher than the Starhopper only got to 150 meters. And the plan is to build Starships and Super Heavies as fast as possible at both locations, the one in Texas and the one in Florida. So they're moving ahead very rapidly. It's surprising how quickly they're moving ahead. They expect the Mark III Starship to be completed by the end of this year. The Mark IV Starship should be completed by the end of February of 2020. And the first Super Heavy should be completed by March of 2020. And at the meeting that Elon Musk had on September 28th, he said they would aim for the first orbital flight in 6 months, which would be March of 2020. So the first orbital flight will be with the Super Heavy and with either the Mark III or the Mark IV Starship. So this year, some new lunar goals were announced. In March of this year, Vice President Pence announced that we would return humans to the lunar surface by 2024. Now, this was an appreciable acceleration of previous plans because the previous plans were not to land humans on the moon till 2028. The new project is called Project Artemis, and Artemis was the twin sister of Apollo in Greek mythology, so they did pick an appropriate name. But the NASA plan to do this does not utilize the Super Heavy and the Starship, and I'll talk about the NASA plan shortly. Now, not to be outdone, in July of this year, Elon Musk announced that he could land a Starship on the moon in 2021, and that he could return humans to the lunar surface by 2022 or 2023. Now, Elon Musk is known for being overly optimistic in his time schedules, so I really don't think he can do it that fast, but if everything went just right, conceivably he could return humans to the moon by 2024, which is the goal set by the Trump administration. Well, NASA is developing its own large launch vehicle known as the Space Launch System, or SLS. And this is also designed to take humans to the moon and to Mars. But there's an important distinction here because the SLS cannot land humans on the moon or Mars, whereas the Starship can do that. Boeing is the contractor for the first stage of the SLS, and unfortunately their performance has been pretty abysmal. Thus far, they've spent $14 billion on the SLS, and there have been no launches. The first launch is now scheduled for late 2020, and that's years behind the original schedule. Original schedule was to launch it in 2016. NASA is also developing the Orion spacecraft, and that's to carry astronauts to and from lunar orbit. It's very similar to the Apollo command module, except that it's quite a bit larger than the Apollo command module. So let's give a comparison of the capabilities of the Super Heavy Starship and the SLS. The SLS is fully expendable, whereas the Super Heavy Starship is fully reusable. The SLS is not capable of orbital refueling, but the Starship is capable of orbital refueling. The SLS can't land on the moon and Mars, but the Starship can do that. Now they're planning to build 3 configurations of the SLS, and the first launch for each of those is scheduled for 2020, then 2024, and 2028. And each new configuration will have more capability. With the Super Heavy Starship, I expect that to be more of a continual type of development with changes being made on almost every flight, at least in the beginning. Now, the first launch of the SLS is scheduled for 2020, and the first orbital launch of the Super Heavy Starship is also scheduled for 2020. So it's a horse race. Which of these will be launched first? The Super Heavy Starship has more capability than the SLS for low Earth orbit missions, but it's not, for low Earth orbit missions, it's not a tremendous amount of extra capability. The place where the Super Heavy Starship really shines versus the SLS is on missions to the moon and to Mars. And that's because the Starship can be refueled in orbit, which more than doubles the payload that can be sent to the moon and to Mars. So what's even more striking is the difference in cost between the 2 launch vehicles. The development cost of the SLS by the time that the third most capable configuration is ready will be more than $30 billion. The latest estimate that Elon Musk has given for the cost of the Super Heavy Starship is $2 to $3 billion. So it's 1/10 this much or less. Now, for the cost per launch, initially, the cost per launch of the SLS will be $2 billion, and over time, that should decrease to about $1 billion per launch. The reason it's so expensive is it's fully expendable, and they're going to have a very low launch rate of at most 1 launch per year. The cost per launch of the Super Heavy Starship should be about $50 million initially, and as they get better and better at refurbishing it and competition comes along, that eventually the cost should decrease to about $5 million per launch. Thank you. So what this means is that initially, for the same cost as a single launch of the SLS, you could launch 40 of the Super Heavy Starships. And then over time, that differential would just increase so that eventually, for the same cost as a single launch of the SLS, you could launch 200 Starships. So here's NASA's plan to return humans to the moon by 2024. And they would first construct a lunar orbiting space station called the Gateway. And they would utilize the SLS and Orion to take astronauts to and from the Gateway. Then they would need a new lunar lander, which would include a descent stage and an ascent stage. Then it's even a little bit more complex than this, because they'll need a new vehicle that NASA calls a transfer vehicle in order to transport the lunar lander from the more distant orbit of the Gateway to a low lunar orbit. So this plan has some flaws. I think Robert Zubrin was very effective last night in exposing some of the flaws of this program in the debate about the Gateway. That it's just overly complex and too indirect. There are too many launches, which lowers the chance of mission success. It's certainly going to be a lot more expensive than alternative plans, and certainly leaves somewhat to be desired. So NASA is planning to fund 2 different landing systems. And they put out a request for proposals. The companies need to submit their proposals by the end of November. And then next year, they're going to award contracts for the 2 competing landing systems. And the reason they want 2 landing systems is for redundancy. It'll be similar to what they do for commercial cargo, where they have 2 launch vehicles and 2 spacecraft independent systems in case there's a failure or something with one system. The other system can take up the slack, which is a very good idea. So the contractors should be chosen next year. And NASA has recommended to the companies that they select its own plan. But NASA has said it will be flexible enough to consider other proposals. So what I'm hoping is that one of the plans that NASA gives a contract to for development of a landing system will go to the Starship. So we'll see if NASA is willing to be that flexible. And this is my last slide. I believe there's a lot of reason for optimism right now, and it's because a lot of progress is being made on the Super Heavy and the Starship that I'm feeling very optimistic. If the Super Heavy and the Starship succeeds, it will be a real game changer. We would have a transportation system that could transport astronauts all the way from the Earth to the surface of the Moon or to Mars, and it would be fully expendable, and it could be done at a cost less than 1/100th of that of an expendable launch system. So it enables just all sorts of things to start happening. I believe that the 2020s will see humans returning to the moon, if not by 2024, at least later in the decade. And I think it's also possible that the first lunar base may have begun by the end of the 2020s. And then I believe that the 2030s will see the first footprints on the red planet. And I'm just hoping I'll still be alive to see that happen. So, questions? Over here.
Musk has upgraded the VFR to empty weight from about 188,000 pounds to 260,000 pounds. Is the amount of fuel needed to get to Mars, is that still the same?
I believe so. I'm not certain about that. Does anyone have any more knowledge about that?
Can we repeat the question? Here you go.
Yeah, go ahead.
Musk just upgraded the empty weight of the Starship from 180,000 pounds to something around 260,000 pounds. Is the amount of fuel needed to get to Mars the same?
I wasn't aware that the weight had been increased that much. So I don't really know. I'm not aware of that. If anyone else knows about that, go ahead.
So in his latest presentation, he did say that the fuel capacity of the Starship had gone up by about 100 tons, from 1,100 tons to 1,200 tons. There is a slightly reduced delta V, but it's still more than capable of getting to Mars as long as it can be refueled in low Earth orbit.
Okay, thank you.